So in the workbook, we're starting on page 79. We're not doing the warm-up. And this is in lesson 6.9. I'm just doing it on notebook paper because I don't have a workbook. And this would be example 1. So if you forgot your workbook and you're doing it on note paper as well, make sure you say what page you're on and what example. Okay? So what we're starting today, these are called solving radical equations. What we were doing in the last several classes was solving rational equations. These are radical equations. So example 1, we have the square root of x plus 6. Then you have a minus 4 that's not under the radical, and it's set equal to 16. So you have a radical equation. Just because you see a radical doesn't make it a radical equation. A radical equation is when you have a variable that's under the radical sign. Okay? So first thing you want to do is, my radical's on the left side of the equation, right? I want to isolate the radical if it's not already. So that means I need to move that minus 4. How would I do that? Add 4 to both sides. So we have the square root of x plus 6 equals 20. So the first thing we did was we isolate the radical if not already. I guess I should say if not already isolated. So now that our radical is isolated, we're trying to solve for x. It is under a radical. Do you think I can just add 6 to both sides? No, yes. I'm going to square it, right? So you know how, like, when we undo something, that's called taking the inverse. So when we undid subtraction, the inverse of subtraction is addition. What's the inverse of multiplication? Division. We think about it as the opposite, but that's not really mathematically. We don't call it opposite, okay? So what is the inverse, opposite, of square rooting something? Squaring it. So if I want to undo the radical, I want to get rid of the radical, I'm going to square both sides, okay? What I do to one side, I have to do to the other. You can't just do it to one side. So I'm going to square both sides of the equation. What do you think the square root of x plus 6 quantity squared is?
400.
Just x plus 6. And 20 squared is 400. Now can we subtract 6 from both sides? Totes. So I get x equals 394. Bless you. Yeah, compared to rational equations? Yes. Now you do have to check for extraneous solutions, okay? Because the number you get, if you substitute it back in and that gives you a negative under the radical, that's imaginary. And we're only working with real numbers. So you do need to check your work. So wherever I see an x, I'll substitute in 394. And I'm just simplifying the left side to see if it equals the right sides, because when I check, there's no variables, right? So 394 plus 6, that's the square root of 400, and then minus 4 equals 16. What's the square root of 400? 20. We know if 20 squared is 400, then the square root of 400 is 20, right? So that gives us 20 minus 4 equals 16. What is 20 minus 4? 16. So true statement, yes? So 394 is your solution. Coolio? Do I need to turn a light on? It's dark outside. It's getting kind of
It's nice.
dreary. All right, example 2. Same page. We're still on page 79. Example 2 says the square root of 10 minus 3x equals x. All right, we have a radical equation. The first thing you want to do is isolate the radical if not already. Do we need to isolate this one? No, it's already done. So I'm trying to solve for x. This x over here to the right, it's fine, but we got to get rid of this radical, so what am I going to do? Not square root it, square, and you're going to square both sides. And I'm doing that in like a second step. Well, it's the first step, but instead of just rewriting in the problem so that when you look at your notes, you can see how your problem changed from how it started, right? So what's the square root of 10 minus 3x quantity squared? 10 minus 3x equals x squared. So this time I have a quadratic term and a linear term. Last time I just had, well, and a constant. Last time I just had the linear term and a constant, so I could just isolate the x, right? What are we going to do next?
So you're going to subtract the x2 and then you're going to solve it like with that a factoring?
We're going to try to factor or quadratic formula or complete the square. Yeah. But I wouldn't subtract x squared because if I do, this is my highest degree, so it's going to be my leading term, and you always want your leading term to be positive. So instead of doing that, I'll just move the negative 3x over and the 10 over. Okay? But yes, you're on the right track. So on the left side, 10 minus 10 is 0, negative 3x plus 3x is 0. On the right side, I don't have any like terms to combine, but I do want to make sure it's in standard form. So that would be x squared plus 3x minus 10. Now, just like Julissa said, to solve this, I'm going to try to factor. If factoring doesn't work, I'll use the quadratic formula because the quadratic formula will always solve a quadratic, or completing the square will always solve a quadratic. If you want to just go straight to one of those methods because you know they work, that's fine. I like to factor. To me, factoring is a lot quicker. So if it's factorable, then that's what I'm going to do. So to factor, first of all, we look for a greatest common factor. Do we have one? No. Define A, B, and C. A is 1, B is 3, and C, negative 10. Make your little T-chart. You need two numbers that multiply together to get A times C.
5 and negative 2.
Hold on, let me set up the chart. A times C is negative 10, and they need to add to be positive B. I didn't mean positive B, just add to get B, and B is positive 3. And I'm sorry, what did you say?
5 and negative 2.
5 times negative 2 does give me negative 10. 5 plus negative 2 does give me positive 3. What was that? So, that works. My factors are x plus 5 and x minus 2 because 5 and negative 2 is what worked on both sides. Will we need to divide and slide? No, why not? Because A is 1. If A is anything other than 1, then we would. So those are my factors. But have I solved? No. Set each factor equal to 0. Good. So if you were at home, you were absent, and you were being the good little students that you are, and you're watching the video and taking notes, and say there's things I don't like, I'm saying set each factor equal to 0. Guys, it's rained. It's rained lots of times in your life. Let's pay attention to this. And I don't write step by step what to do, but you feel like you need that in your notes, then you can quickly jot down. That's what I do. When I was in school and my teacher wouldn't write it down, when they would say it, I knew when I went back that I probably wasn't going to remember that, so I'd write it in real quick. Okay? Please, by all means, do that if you need to. So here I'll subtract 5 from both sides. X equals negative 5. And x equals positive 2. Of course, I need to check myself before I wreck myself. And I have 2 answers this time. I have to check both of them. Usually when you're going to get an extraneous solution, it seems to be like when you have 2 solutions. Just because you have 2 doesn't mean you're going to get an extraneous solution. That seems like when it occurs. Or I should say more likely to occur. So I have 10 minus 3 times negative 5 equals negative 5. So that gives me under the radical 10 minus 3 times negative 5. Negative 3 times negative 5 is positive 15. That gives you the square root of 25 equals negative 5. I'm sorry. Yeah. Square root of 25 is negative 5. What's the square root of 25?
5.
It is 5. Hold on. I'm going to see if they want us to do the positive and negative. No. Now, I know the square root of 25 is positive 5. It could be positive or negative. But according to the book, we are just taking the positive square root, which is 5. That's called the principal square root. And 5 does not equal negative 5. So what kind of solution would we call negative 5? No.
Not a solution.
No. Well, it's not, but
Real solution?
what were you saying yesterday?
Extraneous.
Extraneous.
Oh. See, you kind of tricked me there.
No, I wasn't. What'd you say you call it yesterday, Julissa? Exorcist or something.
Exorcism.
Yeah, it's not exorcism. It's extraneous. So if you have an extraneous solution, that's not a solution. It doesn't work. All right, well, let's see if 2 is a solution.
Don't they both have to work?
No. They don't both have to work. So that would be 10 minus 3 times 2 equals 2. So that's 10 minus 6, the square root, I'm sorry, square root of 10 minus 6 equals 2. 10 minus 6 is 4. Does the square root of 4 equal 2? Yeah. So 2 would be our only solution.
I kind of like these problems.
Yeah? Kinda.
Kind
How are we gonna switch lunches?
It is easier than the rational equations, yeah. I don't know. I'm recording.
Oh my god.
Example 5. Example 5. I'm 3. Where did I get 5 from? Example 3 is on page 80. Example 3, page 80.
On the test, you know how we did the rational problem?
Yeah?
You should use one that we did that you know doesn't have all that quiz.
I'm not gonna make those hard on the test.
Students and staff, students at this time, those of you that are at lunch, please go into the cafeteria. Please go inside the cafeteria so that you are out of the weather. Staff, we will be bringing you more information before the bell rings for the next class in regard to rainy day. Thank you.
Okay, on this one, we have radicals on both sides of the equation, don't we? So to isolate, to move stuff from one side to the other, you've got radicals on both sides, okay? So the way we would start this off is we would square both sides. Square both sides. So what's the square root of x plus 7 quantity squared? X plus 7. What do you think 4 times the square root of 5 quantity squared is? 16 square root. It will in a minute. I just want to show my steps. 5 squared is 25. Or you could have gone ahead and said, what's square root of 25? 5. And then remember, you multiply it by anything that you already have outside of the radical, coefficient of the radical.
Can you show me how you got that real quick?
Yeah. So 4 square root of 5 squared, that means the same thing as 4 times the square root of 5 times 4 times the square root of 5, right?
Staff and students, those students who are dismissed from third lunch, stay under the covered walkways as you are heading back to class. Fourth lunch, as you go to lunches, please stay under the covered walkways. When you get there, stay inside the cafeteria. Students who are in portables that are at lunch right now and you would have to get wet, stay in the cafeteria for now. Thank you.
I agree. Okay. All right, guys, I'm still recording this. Your coefficients, you multiply those together. 4 times 4 is 16. And then your radicand, that's what's under the radical, you multiply that together. Okay? And then we made a perfect square because we multiplied two factors by a factor by itself. So the square root of 25 is 5. I'll multiply that by whatever's already outside the radical. Okay? And then 16 times 5 is 80. Subtract 7. And x equals 73. No. Not at all. Let me just check my solution. Yes?
What did you write on the side?
Over here, she asked me to explain how, when I simplified 4 square root of 5, she asked me to show how I did that. And so I just wrote 4 square root of 5 times 4 square root of 5 and then showed my math on it. So I'm going to check this into my original. I would have the square root of, instead of x plus 7, I'll put 73 plus 7 equals 4 times the square root of 5. 73 plus 7 is 80, so the square root of 80 equals 4 times the square root of 5. I'm going to leave 80 is not a perfect square, so I'm going to put it in my calculator, see what I get. Square root of 80 is, let's go with 8.944. 4 square root 5, so I would do 4 square root 5, and I get, you can't see it, and I get the same thing. So that makes a true statement. X equals 73 is my solution. Anybody have a question about that? All right, look at the word problem on example 4. Word problem on example 4. A consumer purchases an item that costs P dollars on a credit card that charges 18.5% interest. After 6 years, the balance on the card is $4,430.27, and no other purchases or payments are made. What was the original cost, P, of the item purchased? Okay? The book says, recall that when the compound interest formula is solved for the variable r, the resulting equation is r times a times p, wrap, equals t minus 1. So they took that compound interest formula, that we're used to using, like a of t equals a times 1 plus r raised to the t. So they took that, I'm sorry, I'm trying to figure out what they did. Hold on, let me figure this out, how they did this. I don't know. It's not looking right. We're going to skip this one. We're going to skip this one because it's not adding up to me, and I need a little bit more. I need a little more time to look at that. All right. So turn to page 83.
Let me guess, 1 through 7.
We're gonna do some of these. Y'all are gonna do these on your own. Let's just do.
Wait a minute, I have a question.
Yeah.
It says on number 2 there's a little 3 right there.
Okay, that's a cubed root.
Who?
A cubed root. So let's do 2 together.
And then there's a 6 and a 5.
Let's do 3 together. 2 together. 2 together. 2 says the cubed root of 2x minus 5 equals 3. So you know how when we say I have a square root, there's no number written there? If there's no number written there, it's automatically implied it's the square root, meaning 2 of the same factors. If there's a 3 written there, it's looking for 3 of the same factors, okay? We can't take the cubed root of 2x minus 5. So what do you think the inverse of taking the cubed root is? The opposite of taking the square root is squaring. What's the opposite of taking the cubed root?
Where?
Cubing. So I will cube both sides of the equation. What do you think the cubed root of 2x minus 5 quantity raised to the 3rd power is? Just 2x minus 5. Because that means I have 2x minus 5 3 times. So if I just need one of them, it's just 2x minus 5. What do you think 3 cubed is? 27. It does not mean 3 times 9. 3 cubed means 3 times 3 times 3. 3 times. Multiply together. Now what? Add 5. 2x equals. What is it? 32?
32, yeah.
Divide by 2 and x equals 16.
So I have a question.
Yes?
Basically, whenever we're doing problems like that, like for number 5, we'll do the 5th and we'll multiply it
5 times.
You'll raise both sides to the 5th power. Yes, on number 5. So on number 6, Number 6, after we isolate the radical, we'll raise both sides to the 6th power because it's the 6th root. Okay, just let me check this real quick. So instead of 2x minus 5, I'll do 2 times 16 minus 5. So what's 2 times 16? 32 minus 5 equals 3. So the cubed root of, what's 32 minus 5? 27 equals 3. What do you think the cubed root of 27 is? 3. It is. If you do a little factor tree and broke 27 down to prime factors, let's see, 27 is 9 times 3. 3 is prime, right? 9 is 3 times 3. 3 is prime. So when you take the cubed root, you're looking for 3 of the same factors. Do I have 3 of the same factors?
Yes.
So it's just saying, which factor did you multiply by itself 3 times to get 27? Well, you multiplied 3 by itself 3 times to get 27. 3 times 3 times 3 is 27. Square root, you need 2 of the same factors. What's the square root of 9?
3.
3, because you have it 2 times. 3 times 3. The cubed root of 27 is 3, because 3 times 3 times 3 is 9.
What about the fourth root?
Then I would need 4 of the same factors.
So would it be all 3s?
Well, the 4th root of 27 is going to be a decimal.
Yeah,
Okay? But like 81 is a perfect square, and it also has a perfect 4th root, because you can 3 times 3 times 3 times 3 is 81. Okay? So 4th root. You could put this in your calculator. Y'all watch me, okay? Watch me. Watch me. If I wanted to find the cubed root of 27 in the calculator, what you do is you don't just hit the little square root button, because that's square root. That means 2 of the same factors. To find cubed root, you see this math button over here on the left? You would hit math. Option 4 is for cubed root. So either scroll down to option 4 or just press in the number 4. And that looks weird, but it means cubed root of 27. Enter 3. Okay? Is 27 a perfect square? No, the square root of 27 is this number. This number times itself gives me 27. Okay? 27 has a perfect cube. It's not a perfect square. So I want y'all to do on page 83, numbers 1 through 7. Obviously, we just did 2 together, so make sure that's also on your paper. Show all your work. You're probably going to want to do that on a separate sheet. I don't want you trying to cram 7 problems on the same page. Okay? If you are, I have lots of kids absent in this particular class that I'm recording, and you may not have your workbook at home. So I'm going to take a screenshot of the workbook page so that if you're trying to keep caught up, then you will have those problems in case you don't have your workbook with you. Okay, but that'll be a separate attachment from the video.